Hello and welcome back to another episode of 5 Minute Materials, the show where we demystify every node in the Unreal Engine material graph. Today we're looking at the Lerp node, probably one of the most used nodes in all of materialism. If we jump into our example here, you will see that using this Lerp node, we're going to blend between two textures. Plugged into the alpha is just a scalar variable. As I take this variable and I tune it up to 1, you'll see that our texture blends smoothly between another texture. So we start at this one, and then as we go forward, you can see if we put this to 0.5, it will be halfway between these two textures. And as we get to 1, it's at our second texture completely. If we didn't have this saturate node here, then it would start to extrapolate rather than interpolate. If we were to go above 1, it would start going beyond our plane of existence and, kill us all. So let's break it down. The Lerp node, otherwise known as Linear Interpolate, is a way of interpolating or blending between any two values, whether that's a scalar value and another scalar value, or it's some 2-vector colors or 3-vector colors, or a texture sample with, RGB and alpha, or a normal map. Literally anything can go into a Lerp function. The Lerp is driven by an alpha. Usually you would be putting in a scalar value, so just a 0 to 1 value. You can also put a texture into the alpha. So if I was to grab a texture sample, and let's say we're lerping between, just for something a bit nicer, lerping between red and blue. If I was to get a noise texture, let's get my packed clouds, and I'll use the red one, and we plug that into the alpha. You can see it's using this texture, which has 1 values where it's white and 0 values where it's black. It is using that as the alpha for the Lerp and driving between these two colors, red and blue. So we chuck that back into the base color emissive, and ta-da, we have a blue and red texture that looks amazing. This is a work of art. When we have a graph that looks like this being 0, this being 1, A is for alpha. And then on this side here, this is our value for our texture or our color or something. So let's say we're lerping between purple and yellow. So purple has a value of 1 in the blue, it has a value of 1 in the red, and it has a value of 0 in the green channel. And then going to yellow, yellow has a 1 in the green, a 1 in the red, but a 0 in the blue channel. As we go from 0 to 1 in the alpha, the blue goes like this, the red goes like this, and the green goes like this. If this was at 0.5, this would be a pretty ugly color. It would be mostly gray and washed out, and so that's why you often get washed out colors in the middle of a Lerp. Now, the reason that I say to clamp or saturate your alphas is because if the alpha was to go below 0 or above 1, then you can imagine if we got this line and extrapolated it outwards. I mean, the red isn't really gonna do much. Same with the green, and we, extrapolate it outwards. Then if we were to put the alpha at 2 or something, then our green would be very, very bright. It would be above 1, and the blue would be in negatives. And that can cause problems if you're using emissive textures, or you might sort of get like negative colors when you're lerping between two textures and stuff. So clamp your damn alphas. You can also use animated things in the alpha of a Lerp. So if I was to get this and pan it or something, then you can see the texture is animating and still maintaining those colors. We can also go another step and, do a sine wave after this. And if we were to get time and add that before the sine wave, then we would get some very trippy results where, lerps between them. And still the whole time, wherever there is black, it will be blue, and wherever it is white, it will be red. You can also use a lerp if you're really lazy and you don't like doing maths and you need to get between two values. So let's say I needed to go between 0 and 100 so that I could make my cube float up and down or something. Plug time into the sine and put that into the alpha. It will linearly interpolate between 0 and 100. Or let's go 500 just to make it a bit more obvious. If we then hit save, then our cube should be floating up and down. Yeah. Exactly 500 units up and down, which is fantastic. So anything that outputs a 0 to 1 value can be used in an alpha. If you're worried about it going over 1, you can saturate it. Because this sine node goes from +1 down to -1 and then back to 0 and whatever, this will make it look like it jumps up and then stops abruptly, like this. Loop, loop, loop. If you want to know how to remap a sine wave or a cosine wave, or if you want to know what time is doing, then you can check out my tutorial here, and also my tutorial here. I use lerps in my grass, I use lerps in my trees, in my bushes, in my landscape, making an auto material that goes between grass and cliff automatically uses a lerp. Everything here uses a lerp. The snow on top of these rocks uses a lerp. This house has lerps in it somewhere. You will never escape lerps. Lerps are the ones pulling the strings, okay? Something that I literally just figured out then is that you can actually put a 3 or a 2 vector into the alpha and it will lerp each individual channel based on what the value is. So if I have this starting at 0, 0, 0 and it's lerping to 1, 1, 1, but I have the alpha be red 1, then it will only do the red channel between these. That's just something that I just found out. So that about wraps it up for today. To sum it up, lerp linearly interpolates between two values when you're going from 0 to 1 in the alpha. If you go below 0 or above 1 in the alpha, then you end up extrapolating, which can get really fucking messy. So saturate or clamp your alphas. For the love of God, saturate
or clamp your alphas.
Anyway, if you found this educational and or entertaining, make sure you drop a like and a subscribe and share this video with a friend or someone that you think needs to know about our lerp overlords. If you're having any trouble with Unreal Engine at all, check out our Discord. And with that, I say goodbye. Goodbye.